Hello, pre-calculus class. Welcome to the second week of digital school. Just a little reminder about a few things. Please be watching these videos. Please be working on your own work independently. I've been running into some issues as I've been looking through some of your homeworks. Please be checking your grades. I was a little bit gracious because there's a lot of you who probably should have received zeros for things, but I did not put them into zeros. Please make sure you're working independently. I completely understand if you have questions and you're asking another student, but please know that I am also available from 8:30 to 3:30 every day on email or Hangouts or anything like that. Sometimes I take some time after school off. I think I told you that, but once again, if you want to meet up with me later, just try to arrange a time. Today's lesson is back to matrices again. And I apologize, the other day I mistakenly labeled the homework section 7.4, which also brings up a great point. I don't really care how you are doing your homework, as far as submitting it. I don't care if you're submitting it to Classroom. Some of you have been telling me you're having trouble uploading it to Classroom, which I don't understand all of that. And sometimes it takes a PDF file and sometimes it takes a picture, but sometimes it doesn't. I really don't care how I'm getting your homework as long as I'm getting it. But I also know who you are and what class you're in, but when you just send me an email and there is no subject, it makes it really hard. Like if I'm trying to find your homework 7.1 and I can't find 7.1, I have to go through like every homework assignment from you. So if you would please, when you are going to be emailing me your homework, please make sure as the subject. If you want to write pre-calculus, you can. I know who my pre-calculus students are. It just might help filter things a little bit as well. But at the top, write like homework 7.4a. That's what today is. It actually is called real 7.4 since I mistakenly labeled 7.4 the other day. But please make sure you're labeling it that way, and please make sure you're doing your homework by yourself, guys. You need to be understanding how to do this, and it's not helpful for me to get all these homeworks and check-ins that are like, hey, we got the same answer, especially when they're the wrong answer. Come on, guys, you're better than that. So anyway, today we're doing the first half of a lesson. If you notice, it does just say 7.4a. When we're working with matrices, especially matrices that are square matrices, so that would be like a 2x2 or a 3x3, there is some special information we can do, and that's why I did the systems of equations the other day. It's kind of weird. In a few days, we're going to make that into a 2x2 matrix, and there's certain things we need to do with that 2x2 matrix to help us figure other things out. One of those things is something called a determinant. Okay, determinant is a little mathematical thing we do in a square matrix only. So number one, if it is not a square matrix, you cannot find the determinant. So if you can't find the determinant, you just say, I can't find it. And maybe that means the next few steps you can't do. So today we're going to focus solely on finding the determinant. One time we're going to find it. I have several examples for 2x2s. They're short and easy. And that's why I have a few examples so you can do them by yourself and then whatever else. But then I have a few with the 3x3. 3x3 takes a little bit longer, but it's not too tough. You might want to have just a very simple calculator next to you because some of the calculations that we do are not hard, but they're just multiplying numbers together that end up giving us a little bit bigger values that are not out of our brain range, but just a little bit easier to use with a calculator. So you might want to make sure you have a calculator nearby for today's examples. All right. So to find the determinant, it's actually pretty easy. The 2x2 is a lot easier again than the 3x3. Not that the 3x3 is hard, there's just an extra step or two. So if you would please copy down this first example. Sorry because of how quick they go. Actually, if you want to copy down both of these examples. But what the determinant is a value that helps us determine if we can go farther in and helps us figure things out. And so what you're going to do is sort of cross multiply. So you're going to start at the top here and multiply your way down. And then you're going to start at the bottom and multiply your way up. Please think about crossing that way because I am going to give us a hint in something here that we do in just a minute. All right. So that is all you have to do almost, except then we have to combine those two values. And the other day, our answer, when we were doing multiplying, our answer stayed as a matrix. When we find the determinant, our answer is just a single number, one number. So that's going to be important knowing that I did two multiplications here. But What is 5 times 1? All right, so that answer is 5. What is 6 times 2? That answer is 12. Now, we always multiply sort of down first. So 5 is our most important number. Whenever we multiply down, and the reason I'm kind of going to do it this way is because when we get to the 3 by 3, we keep the same sign of whatever when we multiply down. So we're going to keep that 5. Again, I made that circle bigger because there's more answers of that sometimes. But then whenever we multiply up, when I start at the bottom of my matrix and sort of do my up cross, I am going to make that one the opposite. So since 6 times 2 is 12, right over here on my list, I'm going to write minus 12. Because I found 12, the opposite of that is minus 12. And so 5 minus 12 is negative 7. So my determinant of that first one is negative 7. There's a few ways you can label that if you are looking for other resources to help you. Possibly, number one, you can try to find me as a resource. But sometimes if you're looking up things, they will make them look like absolute values. Do not think that means anything about actually making absolute values. But if you are looking up something online and you see straight lines, that does mean determinant. So sometimes we see determinant labeled that way. If I would have called this purple matrix, sorry, I just wrote it in pen, matrix A, there could be an answer of the determinant of A equals negative 7. Again, those straight up and down lines mean determinant. Or for what we're doing today, you can just write on all your answers, DET to stand for determinant, DET equals negative 7. So all your answers today, you can just write DET equals negative 7. And again, because of this right here, you might be able to look at your picture and know what those two values are. Please remember, you always cross down first, and that answer is kept the same. So if I cross down first, I get 8 times negative 3, which is negative 24. But then if I cross up, be careful, I get negative 4. But since I get negative 4, I'm going to write plus 4. And so the determinant is negative 24 plus 4, which is negative 20. Ladies and gentlemen, just the two examples I have written down so far happen to be negative. It does not always come out that the determinant is negative. I have no idea what all of my answers are going to be. I was just thinking of random numbers. Again, if we would be in class together, I would have weaved through the room and asked you things. But sorry, I was talking. Hopefully you had time to copy those down. Cross down first. 7 times negative 7 is negative 49. That one I keep the same because it's a cross down. Cross up, I get negative 5 times negative 5. That's negative 25, but remember, I got to switch the sign of that second one. So I would get plus 25. I just want to be sure, negative 49. Negative 49 plus 25 is negative 24. And so the determinant of this problem is negative 24. Guys, it looks like I have given you all examples that have negative determinants, but please do not think that your answer always has to be negative. Oh yeah, there's one more. Let's look at this one. What's negative 8? My fault. Negative 3 times 8. Negative 24. Cross up. What's 6 times, negative 6 times 4? Oh yeah. Guys, we could even do this that we get an answer of 0. Again, in a few days, if we get an answer of 0, that determines something else that we can or cannot do. And so if you get a determinant of 0 today, that's fine. You can write down determinant is 0. But in a couple days, that's not going to be good for us. So just remember that. So you can get anything as your determinant. There's going to be some times where your answer is really big. There's going to be some times where your answer is really small. Please remember, anytime we cross down, our answer stays the same. When we cross up, we have to make that product the opposite. So we're going to do a 3 by 3 now. Again, a 3 by 3 is not hard, but just make sure you listen to these instructions and follow along. So here's our first example. Pause. So if you think about what I did before, it looked like I made 2 diagonals. So I'm going to draw my 2 diagonals, but you're going to notice something about that. If I make those 2 diagonals, excuse me, the 7 has been used twice. The 4 corners have been used once, but these numbers right here have not been used at all. So I'm going to write the instructions down here, so if you're copying along. Ladies and gentlemen, in order to do this correctly, we need to take our first two columns and rewrite them at the end. So since my first column is 2, 5, negative 2, I'm going to kind of keep my spacing out like that. But if you notice, I copied that down right there. But that's only the first column. I'm supposed to do it for the first two columns. So now I'm going to write 4, 7, 2. Do you see how I took those first two columns and just rewrote them outside my matrix over here? Because now, if we start at the top again, I already have done it, but if I would circle the 2 and cross down, do you see how there's 3 numbers in that diagonal? If I circle the 4 and cross down, there's 3 numbers in that diagonal, and by the way, that 2 was used for that one. And then if I circle the negative 1 and cross down, I have now used the 5 and this 2, which were not used before. And so although it looks weird, I have used every single, because if you look at my diagonals down there, I have them circled and arrowed through, and these 3 have actually been used. So I've used every single number now when I've been crossing down. The same thing, let me change my color now though too, so we can see going up. If I already draw in all 3 of those diagonals going up, you can see all these numbers have been crossed out in red, as have these, which means all of my numbers have been used crossing both down and up. Okay? So after we rewrite those, we now have 3 diagonals going down and 3 diagonals going up. So we're going to multiply across on diagonals. Both down and up. Please remember, as we multiply down, we keep that sign the same. So I'm going to be holding this here as I speak and type into my calculator. It looks like my first diagonal is 2 times 7 times 6. 2 times 7 times 6. Since that is a cross down, I keep my sign the same. My calculator was showing me that answer should be 84. My next diagonal down says 4, 3, and 2 is the negative. So please make sure you do that. If I do 4 times 3 times negative 2, I get negative 24. Since this is a diagonal going down, I actually write down negative 24. Because my product told me negative 24, I keep it as negative 24. My next diagonal, sorry guys, starting right here would be negative 1 times 5 times 2, but that 2 is positive, and that would give me a negative 10. So again, I'm going to write these numbers here as well, but my first diagonal down was 84, negative 24, negative 10, so I started my list right there. But please remember, those are only my down diagonals. I now have to look in red at my up diagonals, but I'm still going to write that with the black pen, guys. So I have negative 2 times 7 times negative 1, right? Is that what I'm seeing? Negative 2 times 7 times negative 1. That should give me a positive 14. So up here, I'm going to write 14, but please remember that was my diagonal up. So if I got 14, I'm actually on my list going to subtract 14. My next one would be 2 times 3 times another 2. 2 times 3 times another 2 would give me 12. But as I'm multiplying up, I didn't see any negatives, so I got 12. So on my list down here, I'm going to write negative 12. And 5 times 4. That's a bigger number. 6 times 4 is 5 times 4, is 120. And there were no negatives or anything that happened there, so I'm going to get negative 120. So guys, it looks like we're going to get a really big negative number here because this number was a positive 84. I kept it the same. Negative 24, kept it the same. Negative 10, kept it the same. Got a positive 14, but because that was a diagonal up, I had to write negative 14. Got a, 12, but since I was multiplying up, need to write negative 12. 120, since I was multiplying up, need to write negative 120. And so now I'm just going to type all of those numbers in my calculator. 84 minus 24 minus 10 minus 14 minus 12 minus 120. And when I did that, my calculator told me that my determinant for this answer would equal negative 96. Excuse me, I was writing something and speaking, so I kind of got a little bit discombobulated right there. Determinant equals negative 96. So again, please remember, when you're doing the 3x3, your first job is to rewrite your first two columns. Do your 3 diagonals down as well as your diagonals up. If your diagonal is up, you're going to do the complete opposite of it. And so one more time, we're going to work through this one together, but I'm not going to write all the instructions. Here is the initial matrix. Hopefully you took some time to write that down, and maybe you already did it because you knew you needed to, but you're going to have to rewrite those first two columns. So after you wrote the original, you want to write this. So guys, it sounds like for a 3x3, I need to see the work written down. For the 2x2, I don't need to see the work because I know you can look at the computer and do that. I want to see the work for the answers on there, but I don't need to see the matrix rewritten. For the 3x3, please rewrite the matrix. All right, let's work our way down. I'm just going to do the work with you as we go. I'm having a calculator just to make sure I don't screw up on what I say or do. My first diagonal down is 2 times 3 times 7. That gives me 42. Since it's a down diagonal, I keep it the same. My next diagonal is negative 5 times negative 4 times 1. Those negatives cancel each other out, so that becomes positive 20. And since I'm multiplying down, I'm going to write positive 20. My next diagonal is 4 times 6 times 5. And since that's a diagonal going down, I keep the sign the same. There were no negatives to worry about, and so I'm going to write plus 120. First diagonal up is 1 times 3 times 4. That gives me negative 12. On my list, as I'm writing it right here, since 1 times 3 times 4 is 12, I got to write on my list negative 12. Next diagonal would be 5 times negative 4 times 2. Now that gives me a 40. Multiplying up, it's negative 40, but on my list, I'm going to write plus 40. My last diagonal is 7 times 6 times negative 5, which 7 times 6 is 42, times 5 is 210. It is negative 210, which means on my list, I'm going to get plus 210. So I'm going to go through now, and I have a 42 plus 20 plus 120 minus 12 plus 40 plus 210. And guys, this one, as I was just randomly picking problems and numbers as I was writing down the examples for you before, it looks like my answer is 420. It's a big number. Sometimes we get answers that are big and crazy. Sometimes we get answers that are small and close to 0. We got an answer of 0 before. It could be small and end up being that way. So please just be careful. Once again, for both 2x2 and 3x3, when you multiply down, you keep the sign the same. But when you multiply up, please make every sign opposite. If you have any questions, please reach out to me. In case I haven't said it, please just email me today saying March 23rd to let me know you watched the video and you're going to be working by yourself, and how it works best for you to submit your homework, whether it's on Classroom or whether it's through email. You can also let me know if your examples went well or not. All right, thank you. Have a good day.